So let me share my screen now. Okay, so today's topic is data science demystified, an introduction to data science. You have already seen my bio in the presentation by the department, and now I'm skipping this slide for the time being. And if you want to know more information about me, you can visit this URL. Right. So let me introduce you some of the topics that I have already included in this talk. First, we will be covering a quick view on data, information, knowledge, and intelligence. Then the types of data, the quick view on big data, the need for data science and the definition of data science, then the difference between the data science and business intelligence, and some of the prerequisites for data science and a typical data science life cycle is also covered in this talk. So let me start with a quote. Everybody who is interested to work in the data science domain might have heard from many people saying data is the new oil. So let me start with a question now. So if I ask you to imagine what was the most valuable resource during the 18th century, you will be having a lot of answers that probably came to your mind. Some of you might have thought about the cash, some of you might have thought about the gold or jewels, right, or other costly materials. But surprisingly, during 18th century, the most valuable resource was the oil. Yes, it was oil. So oil in its very crude, in very raw form, we call it as crude oil. And after several refinement processes, then we will get actually the petroleum and the some other value added products. Okay, so if now I ask the same question, what is the most valuable resource in the 21st century, the answer is not oil anymore. Now the answer to the question is data. Yes, now the data is the most valuable resource. The organizations are vying each other on collecting, analyzing this data for creating their strategic decisions that will lead to the success of the organization. So data is of highly important or valuable resource during 21st century. So let me quickly introduce you some of the topics before going into the advanced data science concepts. So these are some of the technical terms that you should be understanding, right? First one is the data. Now the data, the information, knowledge, and intelligence. So obviously this is a typical definition that we all have learned in our early days. If somebody asks what is data, now we have a definition. Data meaning raw facts. Right. So data is a collection of facts in a raw or unorganized form. It is such as numbers, characters, or the combination of these two, etc. So one major point that to be noted when we talk about data is the absence of context. So what do you mean by context? A context meaning the surrounding facts. The surrounding facts are known as the context. So the context is missing in the data. So consider two examples here. So these are two examples. In the first example, you can see a number 120, 12020. So if this is an example of a data without any surrounding facts. So if I ask you, what do you or what did you interpret from this data? You may be saying, okay, this is a sequence of numbers. Okay, I'm having 8 digits. It's a combination of 1, 2, and 0, right? So if that is the only thing that you can tell from this example. In the second example, there are sequence of numbers 35, 50, 47, 13, and 49. If I ask you the same question, what can you interpret from this? You will be saying these are sequence of numbers. Sequence of numbers separated by comma. That is all you can say from these examples. Okay. So here what lacks is the context or the surrounding facts. Okay. That is the data. Now we are moving on to the next hierarchy, that is information. So what do you mean by information? In information, we call it as a processed data. So processed data, so what is the process that we are doing there? We are contextualizing the data. We are bringing in the notion of context into the data. The moment we bring in the context into the data, that will become information. So look at the previous two examples. So in the previous example, we were seeing only numbers, right? In this example, I have added some separation between these digits. So I have added a slash between these numbers 12, 01, 2020, and now it is in a form of a date, right? So now we have contextualized it and it has become a date, or I can say it is a date of birth of a person. Now we have added context. So let's consider the second example. It was a sequence of numbers, right? And now I am saying, okay, these are not just sequence of numbers, but these are marks of 5 students in a class test. Now I have added the context of class test, student mark to the data. Now it has become information. There are a lot of information, a lot of questions that we can ask to the information, like questions starting with who, what, when, where, etc. So I can ask the question, whose date of birth is this? This is how we'll be asking question to the information. Now we are moving on to the one step above, that is known as the knowledge. So when we will be asking certain questions starting with how, right? Certain questions starting with how to the information, that will become a knowledge. Knowledge in the sense, for example, if I'm asking the question, how to improve the marks of those students. Okay, these are the marks of a student. After contextualizing and observing, I came to know that the mark of a fourth student is less than the average. So I will be asking the question, how we can improve the mark of the student, or how the sales of a company can be, of my company can be improved. Okay, how the marketing can be improved. If we ask such a questions, it will become a knowledge. Okay, so how are the pieces of this information connected to other pieces to add more meaning and value? So if we add more meaning and value, that will become knowledge. And in the fourth category is known as the intelligence. So intelligence meaning, in simple terms, it is the applied knowledge. Okay, so you have collected data, you have contextualized it, you have brought in the information, then you have analyzing it by asking a lot of questions. Now that become knowledge, and once you apply that knowledge, it will become intelligence. So when the knowledge and insights gained from the information is used for taking proactive decisions, we can say that we use intelligence. Okay, so or in other terms, we can also say that if the data and information are like a look back to the past, what has already been happened, the knowledge and intelligence are associated with what we do now and what we want to achieve in the future. Okay, so these are the building blocks of data science: the data, information, knowledge, and intelligence. So if you look at this pyramid, there are four components. One is the data, the information, the knowledge, and intelligence, that we have already seen what they are. So data meaning the facts and figures which are not organized in any way, right? Now we are organizing, we are contextualizing, and it will become categorized and condensed, and it is known as the information. And when we ask certain questions to the information on analyzing it, it will become a knowledge. And ultimately, this knowledge, when applied, will be treated as intelligence. So this is the final goal. This intelligence is what the companies are looking for to proactively take decisions. Why they should take decisions? Decision to boost their performance or to achieve better goals. Okay. So now I have told enough about the data. Data meaning unorganized. It's a collection of raw facts, etc., etc. And now let's look into the types of data that we have around us. The types of data primarily are categorized into three. One is called the structured data. The second is the semi-structured data, and the third is the unstructured data. Now let's look into what is structured data. So structured data, as the name implies, It is organized. There is a structure to represent the data. For example, most of the application programs or software systems that generate the data, which are stored in relational database management systems or RDBMS in the form of relations or tables, comes into this category. For example, if you are developing a student management system or an attendance management or a hospital management system or something else that uses relational tables to represent data, then that comes under the category structured data, meaning the storage and retrieval will be efficient. Why efficient? Because all these relational tables will be having a relational key associated with it. Using that key, we can efficiently retrieve the data. The second category is known as the semi-structured data. Semi-structured data is not so sophisticated or not so structured when compared with the structured data, but there is a format. For example, XML or extended markup language. So XML data is an example of semi-structured data where you have some mechanism you can define, user can define tags, the tags that has been written in angular bracket, and you can represent the data and then you can close the tag. So that is one sort of representational mechanism, but that is not so structured when compared to the structured data. XML is an example of semi-structured data. So if you process the semi-structured data using some tools or techniques, then you can represent, you can store the data in a relational database. So that is a second category of data. And most importantly and most interestingly, the third category of data comprises of 80% of the more than 80% of the data that we see today, or the programs generates these type of data in a very huge quantities. So it is often represent around 80% of data. So some of the examples of the unstructured data, or unstructured text data that we are generating from our social networks. So think about the quantity of data that we are generating in unstructured form. The moment I am talking to you, right, I'm taking a session to you, and I have my video on, and I have my audio as well. So these are treated as unstructured. Why it is unstructured? Because it does not have a proper structure to represent. So if I am taking my voice and asking you to put that in a table, then that cannot be done because it does not have a proper structure. Right. So here implies a lot of scope for a data science, because the organizations are generating these sort of data in a very huge fashion. So it can be multimedia content. Multimedia content meaning the text will be there, then audio, video, images, etc. So this is one type of data which needs a lot of attention. Okay, I hope now it's clear the types of data, the structured, semi-structured, as well as the unstructured data. So companies are investing a huge amount of money in this area. Why? Because all the companies are generating this sort of data, and they need to find out what is inside this data. Why they should find out what is inside this data? They should find out some interesting patterns people are talking, or that has been generated from the system processes. Then only they will be analyzing it and taking some crucial decisions. So this is one interesting fact. Do you know the 90% of the data around us was generated in the last few years? Because in the earlier days, the ICT, information communication technology, was not so sophisticated, right? So the applications that produces and consumes the data was very less. But now the situation has completely or tremendously changed. Now all the applications, all the organizations have huge amount of data generated, which, I mean, in some organizations those things are kept in silos without doing anything, but in some organizations they are building some intelligence tools and techniques to analyze this data. But if you check, the 90% of the data that we see today has been generated in the last few years. That is an interesting fact. Now, when I say the huge amount of data, many of you might have heard this term, the big data. So what do you mean by big data? So big data is relatively a new term, but it is a collection of tools and techniques. Big data doesn't mean that the data is big. Obviously, the data is big, but big data comprises of all the data associated tools and techniques that will be used to process huge amount of data. Why we need big data or big data infrastructures? Because the traditional programs cannot deal with such amount of huge data, right? So data is so big, that's why it is called a big data. It cannot be processed using traditional approaches. Okay, so big data is not mere data, but the tools, techniques, and various frameworks. So we will be combining these together and terming it as big data. So big data, earlier days, the companies were not investing most of their money in big data, but now they have identified the usage. Now identified the how valuable the data the companies are generating. So what comes under big data? So big data, these are some of the examples of big data. Some of the examples. There are many examples that we can say about big data, but this is one is a black box data. Obviously, the flight communication data. The moment a flight start or depart from one airport till it reaches the destination, there is a hell lot of communication that are happening in between the ATC and the pilot, right? All these things are being recorded. So that is one example, black box data. The social media data. Now we have a lot of social media platforms in front of us in our mobile devices. The Facebook, the Twitter, the Instagram. So all these platforms are generating terabytes or even petabytes or zettabytes of data. Right. So that needs to be analyzed. Then now comes the stock exchange data, the power grid data, the transport data, the search engine data. So all these data fits in the category of big data. So now you are in a better position, I suppose. These sort of data cannot be processed by using a single computer or a single process or a single program that we write in Java or in C++ or C cannot solve this issue. That's why we need a big data. So initially people were talking about the 3 V's of big data. The 3 V's meaning the first V represents the volume, second represents the velocity, and the third represents the variety. So initially when big data was gaining some attraction, people were talking about these three: the volume, velocity, and variety. What do you mean by volume? Of course, the quantity of data. Velocity meaning the speed at which the data is being generated. So in the case of Facebook, right, we all will be using Facebook and are posting videos, images, and think about how many posts will be created in the back end of Facebook on a single day. There are millions of users across the globe for Facebook. That is the case with any other social media as well. So think about the amount of data or the speed at which this will be created and the variety. In the post, you will be typing some text, you will be attaching a video, then you will be attaching some images. So there are different types of data, right? So the audio data, the video data, the images. So all these things comes under this V, that is variety. So after certain evolutions of big data, this has people have added 2 more V's into the 3 V. That has become 5 V. 5 V's are the volume, velocity, variety are there. Along with that, they have added 2 more V's that are veracity and value. So veracity meaning the data should be in a better fashion. Better fashion meaning it should not be junk. So big data. As you imagine, the data is of. I mean, we need quality data, right? That quality data needs to be processed. There should not be any junk. So veracity aspect of the big data deals with sanitizing the data or making sure that the data is clean. And the next one, the 5th V is the value. The value meaning how the organizations or the enterprises are benefiting out of it. So initially started with 3 V, then 5 V. So now people have added 2 more V's into this 5 V, that has become 7 V's. So volume, velocity, variety, veracity, and value is already there. There are 2 more V's that are variability and visualization. So variable meaning something that changes its value, right? So variability meaning the data that we see one day is not the same on the other day. There are variations in the data, right? So that is a variability aspect. And a visualization, which is more important because to take a strategic or crucial decision for the managers, right, we need to properly show them the visualization by means of the chart, the graphs, or tables, or any other sort of visualizations, then only they will be analyzing it, because they are not tech people. They don't know how to write a. They may not be knowing, right, how to write a code to fetch the data to visualize it. So there are people, tech people, who are very good at creating interesting visualizations, and these visualizations will be presented to the top level managers. On seeing the visualization itself, they can identify the pattern. Okay, this year this location has the lowest sales, so we should change our strategy to promote the sales. So this is how the 3 V's, 5 V's, and 7 V's of big data. These V's are ever increasing, and people are adding more and more V's. But for the time being, 3 V's, 5 V's, and 7 V's are important. So big data. There was one solution that you might have already heard. The Google proposed a solution which is known as MapReduce. So MapReduce was one algorithm that was proposed by Google how to tackle the big data problem. Then later, the dog cutting and Mike Caffarella, and these are the people along with their team, has taken this from Google and open sourced that, and this is the Hadoop. The Hadoop. So Hadoop is a popular infrastructure for analyzing big data, and they have their own file system called HDFS, Hadoop Distributed File System. So the Hadoops are a collection of computers. Those are clusters of computers. So if you have a big data, then you will have a master. Then that master computer will be dividing that task and splitting those tasks into multiple units and assigning to different computers. So that will become distributed, right? So once they complete executing, the master computer will be getting or fetching the result back, and then that will be the final solution. So Hadoop will mostly running in clusters. Okay, so this algorithm is popular in big data or in data analytics in general, MapReduce and the Hadoop. So now I'm moving on to the need for data science. Okay, we have heard enough about data, information, knowledge, intelligence. What is data science, and why do we need actually? Why do we need data science? Okay, so if I ask this question a couple of maybe 2 years or 1 year before, this question was very exciting for you. Does the thought of your car driving you home by itself excite you? The answer would have been yes. But now it is not a myth. It is actually a reality. The autonomous cars, right? The autonomous cars, a lot of research and development activities that are happening. So this is where the data, this need for data science comes into picture. The data science helps in making better decisions. This is the ultimate aim of data science. It will help in making better decisions. So in the case of an autonomous car, how data will help? So there are a lot of sensors deployed, right? The data capturing unit deployed, which will be observing the road data, what is the condition in the road, and also the condition inside the car. Okay, so these sensors are collecting data in a frequent manner, maybe if the data points in every milliseconds or even seconds. Then it will be taking decisions when to apply brake, when we should stop the car, when we should accelerate. So all these decisions are being taken by the car by using the data generated by the sensors. Okay, so ultimately there is a mechanism or there is a system which learns the patterns from the data, and which is known as the machine or machine learning, right? So there will be some moment when we have enough data, and the machine will be taking the decisions based on that data. Then we say the machine has learned something. Okay, so this is a need for data science. Need for data science in the case of an autonomous cars. Okay, sensor data, then the sensor data will be processed. It will be taking decisions out of data. Now the second case. Okay, think about a call center, the flight booking call center, right? So if you are a frequent flyer, these are some of the messages that probably you will be getting from the flight customer care executive. We are extremely sorry to inform that your flight has been delayed by 4 hours due to bad weather conditions. Or else we are extremely sorry to inform you that there are no flights for the time selected. So here, a bit more complex one, we regretted to inform you that your flight has been cancelled due to delay from Airbus on account of engine delivery. Right. So why these things happens? Why these situations happens? Because the data, the sufficient data was not there, or even if the data is there, they are not using that data for taking or optimizing their businesses. So due to lack of data available, flights are often delayed or cancelled at the last minute. So due to improper route planning, your customers don't get flight for the desired time and duration. For example, if there is a bad weather condition, if the flight is not taking that weather data from the appropriate channels and analyzing it, or doing some prediction kind of things, then they cannot optimize the route planning. They have to cancel it. Right. So incorrect decision in selection of right equipment leads to unplanned delays and cancel. This is the case. So they were expecting the flight parts will be delivered by Airbus on this day. So they have scheduled the flight, and customers started booking that flight. So due to some reasons, Airbus or else it could not deliver the flight part. So the flight obviously had to cancel. So think about the cost, or think about the loss the company has incurred by canceling a flight. So these are some of the cases where the data, the availability of data is a major issue. This is why we need data science. We need data, right? Then we need mechanism to find out the patterns. Okay, so in the airline area, these are some of the problems where data science is extensively used. With the data science, we can check whether to schedule a direct or connection flights. It will be analyzing the passenger pattern, passenger commuting pattern. Then only they will be scheduling the connection flight or a direct flight. Can foresee the flight delays. Is there any chance of flight delays? These are the things that the flight people using data science, they will be analyzing. Then the promotional offers, who are flying with us very frequently, then they can give some promotional offers, right? Some off-on booking or an auto upgrade or something like that. So deciding which class of aircraft needs to be purchased, if it is an Airbus, or what sort of comfort the people are asking, and all those things. These are one area. Now, there are a lot of areas where I can say the examples of data science, but these three are the most interesting one that I can convince you. The logistics companies such as FedEx are using data science models for operational efficiency. How they are using data science? Because using data, they can find the best route for shipping a particular product, or they will be analyzing, okay, this is the best time to deliver a product, or to deliver the shipments, or the best mode of transport. Okay, they will be analyzing the cost that has been incurred in the previous time when they were using some alternate methods of transport. Then they will be comparing it, and they will be analyzing that, okay, this transport is better. So in all these examples that I have already told you, in all these examples, the decision is taken by means of sufficient data. This is why we need data science. So data science is arts and science of analyzing the data, then finding the patterns, then it will be presented in a better format, so that the stakeholders can take appropriate decisions at the right time. That is important. The managers need to take the decision in a timely manner. That is how the need for data science arises. So in simple terms, or in three terms, we can say data science is mainly used for better decision making. There will be some points where we need to take whether we should go with the route A or route B, or this plan or that plan, right? So better decision making, the predictive analysis. This is important in data science. We need to have prediction models. What will happen next? Okay, if the current sales pattern is continuing like this for 2020, will we achieve the target of 10 million rupees in the next 2021? Will it happen? So the machine can predict, okay, if the sales pattern is continuing like this, you will not achieve it. That is a prediction. So according to that, we can strategize. We can build a strategy for the decision making. The third is the pattern discovery. So these three are the need for data science. It is for better decision making, for predictive analysis, and the pattern discovery. Are there any hidden information in the data? So if you are collecting the sentiment or the reviews of the customers, you need to analyze how customers are responding to your new product. If they are promoting your product, or if you are saying good about the product, okay, you can market the product more. If they are telling some negative aspect about the product, you need to revise the production plans. Okay, this is how the data science works. So actually the definition, what is data science? So before going into the what is data science, consider that you are going to buy on smartphone through online. This is the thing that we will be doing most of the times, right? When we want to buy a smartphone, the first thing that we will be checking, there are people who will be going directly to the shop and buying things. I'm talking about the other half. The other people will be searching it in online. They will be checking Flipkart, Amazon, any other e-commerce sites, and before checking the mobile features, the most of the time, including me, will be scrolling to the customer reviews, how the customers are rating that product, right? If I mean, there are some the hard rules in our mind. So if we see that the reviews, the average review is around 3.0 or below, or 4 and below, then we will not go for it. Okay, if it is 4.5 plus, then we may consider buying it. So that is how the review. Then we will be reading the customer reviews and all, checking the rating. Then obviously we will check for the discount. Is there any discount, or are there any exchange offers? These are available. So this is with the e-commerce. So now comes with the entertainment. And in the entertainment, which viewers like the same kind of TV show, so that in Netflix and all, we can recommend them a better the shows, right? Then the elections. This is one area that always will be having a lot of news that are coming up. The Cambridge Analytica issue and all, right? During their election, the Facebook was having a tie-up with the Cambridge Analytica, and I mean, all those news. So the election, who will win the election? So based on the the people opinion, and as well as the previous data, we will be able to predict this one, which route I should take so that I may reach faster, the route optimization. Will it be raining tomorrow? There are tons of other questions you will be asking right into the data science. So data science, as I said, which is all about collecting the appropriate data, doing the right processing, then building the insights or visualizations, which will help the managers to take strategic decisions for an organization. So now we are moving on to some of the advanced definitions of data science. So data science in general can be summarized into 3 steps. One is step 1, step 2, and step 3. The first step is asking the right question and exploring the data. This is important. So if you want to do a better analysis, you should always collect the data from the trustworthy sources. And of course, the data needs to be undergo a lot of pre-processing, and then you start asking the questions: how this has happened, or what has happened in this year. My sales sales for a particular location is less compared to the other locations. Why that is happening? So these are the questions that you will be asking. So once you have these questions, or in other terms, this step is called a formulating hypothesis. Formulating hypothesis meaning you're asking questions and you are saying like, okay, maybe this is why this has happened. Okay, that is the assumption that you have. That is called the hypothesis. And once you set the hypothesis, obviously you move on to step 2, and you will be modeling the data using various algorithms. Various algorithm meaning there can be classification. As I said, for the customer sentiment analysis or something, you can classify customers into good customers as well as bad customers. Or there can be other things where you can build the prediction models. What you are predicting the sales for the next quarter for a company. That also you can do. Then once you do the step 2, that is modeling, then you will be going to step 3, that is communicating and visualizing the result. So communicating and visualizing meaning you need to create a chart, a graph, or all sort of analysis through visualizations, and this visualization should be presented to the top level managers. Okay, so in this terms, if it is the step 1 is asking the questions, then the defining the data needed for the analysis, the identifying the type of analysis to be done, and communicating the insight with various stakeholders. And in certain organizations, in most of the organizations, these step 2 to 4, 2, 3, and 4, This step 2, 3, and 4 will be automated. Automated in the sense they will be implementing some tools and techniques so that it will be automatically collecting, it will be automatically scrapping, it will be automatically taking the data from the source, it will be doing the modeling, then it will be communicating it will be generating the dashboards. So there are certain approaches like machine learning is implemented, or the classification or a regression model. So these are the types of things that you can use to automate this process. So now, if you know what is business intelligence, obviously the question might have come in, what is the difference between the business intelligence and data science? So data science is a broader term. Nowadays, organizations, to some extent, they are interchangeably using all these terms. The business intelligence, sometimes they say business analytics, then say data analytics, the data science. But the data science is an umbrella term. It is a larger term under which the data analytics and all sort of data analyst roles and all are coming. So now there are business intelligence as well as data science. So what are the differences? So if you check the business intelligence, most of the time the data are structured data. So what is structured data? There is a proper format for the data that is mostly in a CSV or in a table format that will be loaded into business intelligence tools like Tableau or Click is there. So which will generate some insights for you. But in data science, I'm not saying 100% times, but most of the time it will be unstructured data. So we are collecting the web logs, the reviews, all these data that treated as unstructured data. So method used in business intelligence are more analytical in nature. Here in data science, it is more scientific. A lot of research and development kind of activities will be happening in the data science. The skills required in business intelligence are mostly statistics and visualization, because you are dealing with a large data and you need to visualize it. And here in data science, it will be more complicated. You obviously need a statistics, visualization, machine learning, and along with that, you need a lot of domain knowledge. So domain knowledge is also a key factor in data science. Then the focus is on past and present data in most of the cases with the business intelligence, and the present data and future predictions are the focus in data science. So these are the difference between the business intelligence and data science. Now, okay, so this you think this data science field is very fascinating or very interesting, or this is my cup of tea, I should step into it. So now let's see what are the 3 essential traits for a data science professional. Okay, so the data science professional, these traits are the personal traits. I'm repeating, these are the personal traits, not the technical traits. The personal traits are, one is curiosity. This is important. Okay, you have a large set of data. Now you should have an inquisitive nature. You should be very inquisitive to ask questions to the data, repeatedly ask the questions. Okay, why this is here, or why this has happened? Okay, is these things are related? Is there any relation between these value and this value? These are the sort of questions that you can ask. So curiosity should be there with you. The second one is a common sense. So identify the new ways to solve a business problem, to detect priority problems. So meaning, once you analyze the data using the curiosity, you have asked a lot of questions. Now you need to devise the methodology, right? Identify, okay, how well I can solve this problem, or how well this can be optimized. So these are the things that comes in the common sense. And the third one is the communication. So communication is one of the key elements in data science, because you are dealing with the business people. You are dealing with the top level managers of an organization, with whom you will be having interaction. You will be presenting your findings. So communication is also one important trait. So these are the essential personal traits for a data science professional. I'm not saying these 3 are the only traits, but these are important. Okay, now we are moving on to the technical traits. So what sort of technical traits will help you land in a data science career? The first one is the machine learning. So machine learning is a backbone of data science. As I told you, there are systems which can automate these tasks, or automatically identify the data and find patterns. Such sort of algorithms comes under the umbrella machine learning. right? So you should have basic machine learning skills. You should at least on seeing a data, whether, I mean, you should be knowing whether we should go for a classification problem or a prediction or a regression problem. Okay, these sort of things needs to be done, and the machine learning is constantly evolving. Now the trend is being the deep learning, right? So you should be knowing the basics of machine learning, how to train a neural network, or any other machine learning related concepts. The third one is the mathematical modeling. So mathematical models can be extremely useful to make the predictions from what you know about the data. So mathematical modeling is another key that you should have. And the third one is the statistics. Obviously, if you ask me I mean, what percentage should be in statistics, I would say a 50% of data science is all about statistics and probabilities. So statistics is foundational to data science, and it let you extract knowledge and obtain better results from the data. So statistics is one of the key elements. And the fourth one is the computer programming. Computer programming, you should know, say, programming languages such as Python or R, because at the end of the day, you're automating and you need to create some script to automate the processes. So you need computer programming. And the fifth one is the databases. Why you need a database skill? Because from the data sources, as I said, the data will be in the silos that has been kept, maybe in data warehouses for some organizations, maybe in Oracle databases for some organizations. So you need to fetch all those data from the table. So you need to know the basic query languages, the structured query languages, to fetch the data out. Okay, so these are the technical traits. In the previous slide, we have seen the personal traits, and these are the technical traits for a data science career. Then I'm quickly moving into a typical data science life cycle. So these are the things that you will be doing as a data science professional in an organization. The first one is the concept study. Obviously, understanding the problem in a deeper way. That is a concept study. And the second one is a data preparation. As I have already told you, it is in some textbooks or in some reference terms, it will be known as data monking as well. Data monking means you are collecting the data and you are analyzing the data, and you are finding, okay, these are the related columns, or these are the related fields and all. Then you are preparing the data. That is all about the data preparation stage talks about. And in the third one is the model planning. After understanding the data, you are planning which model, whether it is a regression model, whether should I build a prediction model, or should I apply some classification techniques into the data. That is all about the model planning and the model building. Now, using various analytical tools and techniques, data is converted into a model. So once you have trained a model, then that model meaning an abstraction of things. For example, in machine learning, if you refer to a model, that is a model that has been learned from the data. Some patterns has been learned. So this model has been built. Then it will be communicating the result to the key findings to the managers, and most importantly, operationalize. Operationalize meaning, I mean, putting all these things into effect. You are applying the knowledge. That is how the operationalized phase looks like. The final reports, code, technical documents, etc., are delivered to the team. Okay, this is a finding, and this is how you should approach this problem, and this may be a potential impact if you take this decision, and so on. And this is not only the things. Once you operationalize the thing, there is a feedback mechanism. Once you put all this effort into the market or into the problem, then obviously the strategy may change. And after that, again, you need to collect the data and analyze, okay, how well the model is performing. Do I need to change some parameters in the model, or do I need to change some methods for training? So all these things are in a loop. So obviously the feedback mechanism is also there. So concept study, start with the concept study, go into data preparation, model planning, model building, communicate the result, and operationalize. Okay, so concept study. I will be just skimming through the session, so because we have already seen what are the things, concept study and all the steps. Okay, the concept study meaning the understanding the problem statement by carefully studying the business model. So what are the various specifications? What are the examples? What is the total budget if we want to implement this model, or if you want to train the data? What would be the cost associated with? What are the end goals? Then the data preparation, the data cleaning. Obviously, the data will not be clean. It is a transactional data. So there are some fields that you can eliminate, right? You can remove some unwanted rows. There may be some null values and all these things. So all these things comes into data preparation. You are cleaning the data, you are reducing the data, you are eliminating some unwanted data. Data transformation will be happening. It includes a normalization, transformation, aggregation, etc. So normalization meaning there will be a lot of null values in the in your data set. So you should think how you should eliminate the null value. So all these techniques are coming in the data transformation, and most of the times we will be using a lot of ETL methods. So what do you mean by ETL? ETL defines the extraction, transformation, and loading process. So you're extracting data, you are transforming it, and you are then loading the data into the appropriate format. That is all about the ETL, extraction, transformation, loading. Then the redundancy values. Is there any duplications that you can be avoided? So all these things happens in the data preparation stage. So when it comes to the model planning stage, it involves the exploratory data analysis, or EDA. So you're asking it is also known as a slice and dice. Slice and dice means you're slicing the data and analyzing each and every component to understand the model planning. This is important because once you build a model, the effort that you need to put to build a model is very huge. And at the end of the day, after all the process, if your model is not performing well, then you have to do a lot of rework, right? So this is very important. So EDA meaning exploratory data analysis, which is a deeper analysis of the data. That is what the EDA. So in the model planning, you will be using some techniques such as histogram, the trend analysis, and sort of visualization, and the training data, the test data. All these things are being prepared in the model planning. Then comes the model building. So obviously for the model building, you have to use some automated procedures, the machine learning procedures. You build the model. I mean, the task is not only build the model, but to test the model as well. So your data was previously tested into training and test set. So using the test data, you need to check whether your model is doing well. So there are a lot of packages in Python. Python is very popular, and R is also popular. There are a lot of packages which will help you build the model. You don't have to build from scratch. Only thing you have to do is like you need to know which package should be imported, and some sort of Python coding skills as well. So once you do things and you know which algorithm should be implemented, or what sort of algorithm should be implemented on this data, that is crucial. Then you can simply build a model. So data science and analytics. Now, I mean, I've already addressed this question, whether data science and data analytics are same. If the data science can be treated as a house, then the data analytics is actually, it can be treated as a room. That is how it looks like. As I said, the data science is a broader term, and the data analytics comes under it. So data analysts utilize data to draw meaningful insights and solve the problems. Data scientists will be doing much more things. They will be obviously estimate the unknown by asking questions. They will be writing algorithms and building statistical models. That is more of a the research and development kind of activities will also be done by the data scientist. Now, moving on to the last part of this presentation, the types of data analytics. The data analytics can be categorized into 4 types: the descriptive analytics, diagnostic, predictive, and prescriptive. So descriptive analytics meaning what happened. So you have a complete data on the previous sales information for the last 3 months of your organization in front of you, maybe in terms of an Excel or a CSV file or something. And you're asking the question, okay, the sales for this Cochin location is very less. Okay, what had happened? So these sort of analysis on what had already happened comes under the category descriptive analytics. So descriptive analytics collects raw data from multiple data sources to give valuable insight into the past, what has already happened. Then comes the diagnostic analysis. Diagnosis, why something happened. Okay, so you can relate it well to the healthcare domain. So you have a cough or a fever or a headache, or have all of this, and you are going to a hospital to consult a doctor. So doctor obviously will be asking the question, what happened, right? So doctor will be asking what happened. Then there is a diagnostic process, right? Then okay, obviously he was asking a lot of questions. What had happened, whether you traveled previously, or you have a symptom before. A lot of questions will also be asked. So there comes the diagnostic. He will be doing some diagnostic things as well, right? So he will be checking the BP, or else he will be asking us to do a blood test and so on. So these are comes under the category diagnostic. Why something happened. So we already have fever, that has already happened. The doctor is examining why it happened. Okay. Now we are moving on to the predictive analytics. So if the fever is continuing like this, what will happen? What will happen in next 3 days? That is what the predictive analytics will tell you. The predictive analytics will tell you what is likely to happen. If the sales are continuing like this, will we achieve the target in 2021? So will the fever continuing like this, will it be becoming for say a jaundice, or some other disease? That is what a predictive analytics will tell you. Obviously the last category, it is known as a prescriptive analytics. In prescriptive analytics, doctor is doing some prescription. Okay, doctor has examined, after the blood test, doctor has examined that so there is an infection. So doctor has examined that there is an infection, and if you will not treat the infection, this will be converted into some other disease. So the doctor will obviously be prescribing the medicines. So prescribing some medicine to reduce the infection, or to cancel, or to avoid the infection. That is called a prescriptive analytics. Prescriptive analytics, the purpose of prescriptive analytics is to literally prescribe what option to take, eliminate a future problem. Okay. So in the case of sales, if the sales it is predicted that the sales will not be good in the year 2021. So obviously there must be an action which should be taken now to eliminate that issue, so that the company can perform better. So as a conclusion, if we treat the data as a new oil of the 21st century, obviously the data science and analytics is the combustion engine, because the data is being generated in the organizations, and we need efficient data science and analytics tools, techniques, methodologies, research, development, everything, to use this data very efficiently, so that the organization can take proactive decisions. So with this, I am concluding the session now.